Alright, I'm going to do homework set number 5, and this concerns a plug flow reactor. So consider that we have a tube or a pipe or a canal or a river, and we have flowing through it some water flow Q, and we have a concentration going in and a concentration coming out. And those are different because there is some reaction going on, and it's a first order reaction, and so it has formulation of negative Kc. And in this case, that means that as it moves through the plug flow reactor, it decays. And we can think about this as if it was a jar test moving through the system in a plane. That is, the flow through it is going through like a plug, and there's no horizontal mixing. And so there's no dilution going on here. There's only decay, only reaction. So this means that we can model it like a jar test. Or a batch system. And so for a first order reaction, that's like dC v dt is equal to Qn Cn minus Qc minus Kc V, but there's no flows in or out in this case because there's no dilution. Set this to 0. And so then so dC dt is equal to negative Kc, or C is equal to C initial e to the negative Kt. Well, for a plug flow reactor, T is equal to the time to pass through. Which is the hydraulic resonance time of the plug flow reactor, which is equal to the length of the plug flow reactor, the cross-sectional area, divided by the flow. The cross-sectional area is right here. And x is the distance, that's equal to the length. So for this problem, the length, the hydraulic resonance time is unknown. So we're finding the hydraulic resonance time. And remember HRT, same thing as hydraulic resonance time here. So in that case then, we have this solution. So we have C over C in is equal to 0.05. We have 95% removal, which is equal to E to the negative 0.05 times the hydraulic resonance time. So that means that ln 0.05 divided by negative 0.05 is equal to the hydraulic resonance time, which comes out to 60 days. So If the plug flow reactor hydraulic residence time, theta H, is equal to 60 days, and Q is equal to 15 cubic meters per day, then the effective volume of the plug flow reactor is 15 cubic meters per day times 60 days is equal to 900 cubic meters. That's the effective volume needed for the plug flow reactor. So compare this to what kind of volume you would need for a CFSTR. Say this continuously flowed continuous flow stirred tank reactor has a reaction of first order decay with K is equal to 0.05 per day. It's all the same. Same Q, which is equal to cubic meters per day. In this case, for CFSTR, the concentration coming out divided by the concentration going in is Q over Q plus KV, well, that's V effective. And we're setting that to a 90% removal efficiency, which means that C over Cn is equal to 0.05. The flow is still 15 cubic meters per day. And the K value, or the first order decay constant, is 0.05 per day, and that's times the effective volume. So the effective for the CFSTR is equal to 5,700. Oh gosh, let's try that again. The effective for the CFSTR is equal to 5,700 cubic meters. Quite a bit more than required volume for a plug flow reactor to get the same removal efficiency.